Hi there, part two of Geology and Geologic Time. Left off talking about these principles of relative time dating and how you can figure out sequence of events. And superposition, oldest is on the bottom. That this grouping of rock had to become sedimentary rocks before this one on top of it could have been. So there's the Supai group is older than the Kaibab limestone at the top of the Grand Canyon. This is what you're going to have to do as you get into it is be able to look at different layers and tell me which is older and younger. We know that this layer down here has got to be older than these layers, the sandstone layer on top, because of superposition. Then you get into that cross-cutting relationship that if this layer, this dike A, we said most of the time it's igneous rock that comes up through. If it cuts through it, it's younger. That's the rule. So notice it cuts through all of these and goes to the top. So this is younger. Plus it cuts through this sill. So we're able to kind of figure out which one's older and which one's younger. It can also be used not just for igneous stuff like volcanic stuff, but it can be used for faults. Notice this fault goes all the way up until I get to this conglomerate, doesn't cut into it. So I know the stuff it cuts into, the sandstone, see how it's displaced, that is older than the fault, but then eventually the conglomerate is younger than the fault because it doesn't cut through. What type of fault would that be? It's hanging wall going up, so it's reverse fault. That's all stuff we talked about in the last couple of episodes, last couple of weeks. The last part is inclusions that you have in there, and the principle of inclusions is just if one rock is in another, a lot of times it happens with erosion. It erodes part of one rock and then it gets put into a sedimentary rock of another, that the inclusion is younger. Doesn't happen as often as the other three that you use. And in fact, superposition is the one you use to figure out the most things. Unconformities with relative time dating are breaks or gaps in the rock record. In other words, erosions take place. If you want to figure out layers on top of each other, there has to be a layer there in order for one being deposited. Deposition gives us layers. Erosion takes layers away. It's like if you had a book, it's ripping pages out of the book. I'm eroding those pages away. So you don't really know what happened during that time period. And there are three types of unconformities. One's an angular. Anytime the rocks become tilted, we know original horizontality told us they had to be flat. If they're tilted, something happened. Missing time. Disconformities are when you have layers there's missing time in between, parallel to each other. Real hard to distinguish that one. Here's an angular, see? Became warped, folding, and uplift, created them not to be horizontal anymore. Erosion then took all that apart. Look at all of a sudden these layers don't match up. That's an angular unconformity. You also have a nonconformity. Nonconformities can be any angle, but it's when igneous rock basically resets the time. So it melts stuff around it so you don't know what happened. And if we had the Grand Canyon again, you can use all three types here. Notice this Unkar group on the bottom is going a different angle than these limestones and shales. So therefore, there's an angular unconformity. You have a nonconformity because down here at the bottom, I know you can't read it, but that's igneous rock coming up through and it stopped. So you notice this is all metamorphized down here, resetting the clock, changing everything. And then you have a large gap between the limestone and the Supai group. You'd only know that by looking at the fossils that are in it. So there's all three types of unconformities. And then we try to use correlation because some of that missing rock is there. So we look to other areas. So if we're looking, try to find the same rocks that are layered in North America as they are in Europe, or South America as they are in Africa, because we know plate tectonics has moved those apart. If we kind of line them up, we might be able to find fossils. What are fossils? Remains or traces of prehistoric life. What we look at, there's a whole thing on the full PowerPoint of different types of fossils, but it doesn't have to be the actual remains. It can be traces like burrows, footprints. It doesn't actually have to be the remains of the prehistoric life. In order for a fossil to form, it has to be rapid burial, and it has to have a hard part. It has to have something that's going to create that impression. It's going to create the mold that's going to take place. Rapid burial, why? Because just because something dies, it doesn't always become a fossil. It can be eroded away by weather, rain, and wind. It could be picked up by scavengers and ate. So there are lots of things that could cause it to change. But if it gets buried fast,